Okay, so in this key, you're looking at graphing exponential functions, and this is part 3. Now, in number 1, you have this function, f of x. I'm going to go ahead and write it a little bit better. F of x equals 4/5, so 4/5 is your base, and your exponent is the variable x. All right, so this is what this is, okay? All right, now, remember, one of the things you got to remember is that the domain of an exponential function is all real numbers. I can use any real number for x, and I'll get a y value back. All right, so the domain's all real numbers, and that's true for all exponential functions. That is not true for the range. All right, the range obviously depends on where the horizontal asymptote is and whether the graph is above or below it. Okay. All right, now the y-intercepts, since the domains are real numbers, an exponential function will always have a y-intercept. And remember, to find the y-intercept, you let x equal 0. So if I go here and I use a t-table and I let x equal 0, I get 4/5 to the 0 power, which is 1, right? So I get the point 0, 1. All right, so my y-intercept, so the graph's going to cross the y-axis at y value of 1, or if you want to put it as an ordered pair, you'd say 0, 1. Now remember, the horizontal asymptote, that's another easy one to get from here. So the horizontal asymptote is when you look at the form of an exponential function, it's f of x equal b to the x plus c. Well, that constant is your horizontal asymptote. And so if you look at this, you don't see a constant, but it's understood to be 0. So your horizontal asymptote is y equals 0. Now remember, the horizontal asymptote is a horizontal line. Now we're going to denote it as a dotted line, but it's a horizontal line, so you do need to write it as an equation. Don't just put 0. You got to say y equal 0. Okay? All right, so that's your horizontal asymptote. Now if I go ahead and graph the horizontal asymptote, that horizontal line, remember y equals 0 is the x-axis. So I'm going to go ahead and put a dotted line here. So that's where the graph will approach, at some part of the graph, it's going to approach this horizontal asymptote, meaning that the y values are getting closer and closer and closer to 0. That's what we're referring to. All right, so the other thing you need to remember is this. All right, so remember we talked about the fact in previous lessons that if the base of the exponential, and I'm going to go ahead and write it here, if the base of the exponential, okay, so given this exponential function, f of x equal b to the x, all right, or b to the x plus c, whatever it may be, all right, if b is greater than 1, if the base is greater than 1, 1.0, 2.5, 3, 7 halves, situations like that, then f of x is an increasing function. Okay? So meaning that if you have the horizontal asymptote, let's say, being here, all right, so what that means is that the graph will look something like this. Okay, so that's what that means. If the base is less than 1, now keep in mind that the base, remember, is greater than 0 and cannot equal 1. All right, so when I say less than 1, I don't mean a negative number. All right, so maybe I should say something like this: if the base is between 1 and 0. Okay, if the base is between 1 and 0, because remember, your base can never be negative. So if the base is less than 1, between 1 and 0, like 1/2, 0.6, 2/3, things like that, then f of x is a decreasing function. Okay, so meaning that if this is my horizontal asymptote right here, then my y values are getting closer, my y values are decreasing. See that? They're getting smaller and smaller. Here your y values are getting larger and larger and larger. All right, so your y values are getting smaller and smaller and smaller, and they're approaching this this horizontal asymptote, this y value right here. All right, so keep that in mind. Now, knowing what we just talked about, you see right here my base is 4/5. Well, that's a number less than 1 in it. That's what, 0.8? That's a number less than 1. So when I graph this, I'm going to remember that when I graph it, f of x is a decreasing function. All right? So when I graph it, it should look something like this. All right. Now, I need a few more points here. So let's go ahead and plot 0, 1. Now, once I plot 0, 1, once I know where the y-intercept is, I can see that the graph's going to be above the horizontal asymptote, right? And at that point, if you think about it, at that point, I can go and determine what the range is at that point, because remember, since the graph is above the horizontal asymptote, and part of the graph approaches the horizontal asymptote and never touches it, and the horizontal asymptote is 0 here, y equals 0, then I'm going to say 0 to infinity. So see, you can find the range rather without actually graphing it, just knowing where the horizontal asymptote is, or what the horizontal asymptote is, and whether the graph is above or below. All right, so you're going to say 0 to infinity. Now remember, open circle, I'm sorry, parentheses here, because remember the y value is never 0 on your graph. It approaches 0, never is 0. This, no matter how many of these x values you put here, y will never ever be 0 for this function. So if x is 1, let's see what happens. If x is 1, I get y equal 4/5 to the first power, which is, using your calculator, 0.8, something like that, 0.8. So I get 1.8, which is about here. So that kind of made sense, because remember our function was decreasing, so I knew it had to do something like this. So it gets closer and closer to the horizontal asymptote. Now what I'm going to do now is just use the calculator to help me on this side. So let's pick -1. All right, so I want you to think about this. Y equals 4/5 to the negative first power. Now, some of you may remember the fact that if my exponent's negative, and from a previous course you learned that with negative exponents, that if you have a fraction raised to a negative power, you can make that power positive by taking the reciprocal of the fraction. So that's 5/4 to the first. All right, which is, if you convert that back to a decimal, that is 1 1/4, which is 1.25. And even if you didn't know that, I would do this. I would put in your calculator. Just say this. Just say 4/5, 4 divided by 5, raised to the -1 power, press equal, and you get 1.25. Okay? So 1.25. So you get something like this. So you get -1, 1.25, just kind of approximate it. So that's about here, it looks like, okay? And then let's say if x is, let me do that here. Let's say x is -3. All right, -3. Let's see what happens. If x is -3, I get y equals 4/5 to the -3rd power. Use your calculator. 4/5 to the -3rd power. So 4 divided by 5 raised to the -3rd equal. All right, so let's approximate this. That's what, 1.95? 1.95? All right, so -3, 1.95. All right, so -3, 1.95, which is here. So let's see, so -1, 1.25, and then -3. So it kind of looks like it's doing something like this, isn't it? All right. So if we could have done a few more points to make it look a little bit better. Let's say -8. Let's see what happens if we get -8. So y equals 4/5 to the -8 power. Let's see what that's approximately equal to. So using your calculator, 4 divided by 5 raised to the negative 8 equal 5 point, let's just say 6, approximately 6, positive 6, right? Positive 6, positive 6. So negative 8, positive 6, so negative 8. I kind of went a little bit further, didn't I? Okay, so it should have been here. So the graph should have done something like this, right? Okay, so that's what it should have been. That's what it should have looked like. So that was. So I'm going to go ahead and kind of remove this part. So sometimes as you graph this, just like I did, as you graph this, you may realize, even though I said 3 points, I may need to do a little bit more because it doesn't look right the way I've done it. So that's why I went a little bit further, and so I did a better graph using that. Okay, so I'm going to go ahead and kind of remove this little part here. Okay, all right, so that is number 1. All right, now let's look at number 2. All right, number 2. Okay, so in number 2, you have this. You have negative 4x to the x. You may say, all right, well, number 1 was 4/5 to the x, right? So this is negative 4/5 to the x. So the point of this is for me to remind you about, well, what does the negative in front of that base do? That's the idea, okay? All right, so we can automatically, so remember our function is this. Let me go ahead and write it a little bit better. Our function is f of x equal negative 4/5 to the x. So I know what 4/5 to the x looks like. That's this, right? All right, so that's what that is. So let's kind of determine what negative 4/5 to the x is. All right, so you got to remember, we talked about that before in previous lessons a while back when we looked at quadratic functions. So remember the function x squared, what that looked like, and what the function negative x squared looked like. All right, so keep that in your mind. All right, so first of all, the domain's going to be all real numbers still, right? Negative infinity to infinity, because the domain of all exponential functions is all real numbers. All right, and then I can automatically determine what the horizontal asymptote here. Remember, that's plus 0. So my horizontal asymptote is y equals 0. And if I want to, I can go ahead at that point and go ahead and draw my horizontal asymptote. Let me go ahead and do this. So go ahead and draw my horizontal asymptote. And remember, the graph gets closer and closer and closer to that horizontal asymptote without touching or crossing it. All right, now we can go ahead and find the y-intercept. So the y-intercept, remember to find the y-intercept, you let x be 0. So if x is 0, I get y equals negative 4/5 to the 0, right? Well, 4/5 to 0 is 1, so this becomes negative 1. So my y-intercept's negative 1. So right here, that's where the graph crosses the y-axis, right? Okay, so notice this time the graph is below the horizontal asymptote, right? All right, so my y-intercept's negative 1, or if I want, I can write it as 0, negative 1. So the graph is below the horizontal asymptote. And just like we did earlier with the previous one, so remember the previous one I said that we can find the range without even knowing what the graph looks like. Just the fact that here's a horizontal asymptote, the graph is above it, and so I go from 0 to infinity. I can do the same thing here. I don't even need to know what the graph looks like to find the range, because I know that the graph is below the horizontal asymptote, and the horizontal asymptote is y equals 0, so it's going from negative infinity all the way to 0. So negative infinity to 0. That's your range. All right, so you didn't have to know the graph here to find the range, because we knew it was from 0 to infinity. See, and it is from 0 to infinity. Okay, so I know the graph is below the horizontal asymptote. Now, you remember a while ago. So a while ago, keep what we had in mind a while ago. We said if the base is positive, all right, the function increases. If the base is between 0, if the base, I said positive, I got to be a little bit careful. If the base is greater than 1, the function increases. If the base is between 0 and 1, All right, so base is a proper fraction. Proper fraction. The function decreases. All right, but that is the case if that value right here, see that number in front of b to the x, if that's positive. All right, so meaning that the graph is above the horizontal asymptote. But remember when we talked about quadratics, that negative is a reflection. So it's a reflection. So basically, if this is 4/5 to the x here, the negative 4/5 to the x is a reflection about the horizontal asymptote. So I want you to look at this. So I'm gonna write this here. So f of x equal negative 4/5 to the x is a reflection of y equal 4/5 to the x. All right. Now I didn't want to use f of x again because those two. If you say f of x would be the same function, and they're not. So that's why I use y. All right. So that's a reflection. Is a reflection of y equal 4/5 to the x about the horizontal asymptote. And you're going to see that. You're going to see that here. So let's just use a couple more points. So if x is, let's say, 1, if x is 1, I get negative 4/5 to the first, which using a calculator would give a negative 0.8. Okay, negative 0.8. So 1, negative 0.8 is here. All right. So you see how your graph is getting closer and closer to the horizontal asymptote. So you know on this side it falls rapidly, right? So let's pick some numbers on this side. So if x is, let's say, negative 2, I get y equal negative 4/5 squared. I'm sorry, negative 2. X is negative 2, right? So negative 4/5 negative second. So in your calculator, go ahead and put that in there. So parentheses, negative, and then parentheses, okay? Negative parentheses 4 divided by 5 raised to the negative second power equal negative 1.56, so about negative 1.6. This is approximation. So negative 1.6. So that's here. So negative 2, negative 1.6 is about here. Okay? And then let's say negative 7. So you see it's kind of doing like this, right? So let's pick some numbers further on this side. So negative 7. So I get y equal negative 4/5 to the negative 7th power. So negative 4/5 to the negative 7th power. Let's see what that is. So negative, in parentheses, 4 divided by 5 raised to the negative 7th power equal, so negative 4.8. So it's about negative 4.8. So we get negative 7, negative 4.8. So that's about here. Negative 7, negative 4.8. About here. So it looks something like this, right? Okay. All right. So that's the graph of this function. All right. Now what I want you to know is this. Okay. So listen carefully. So we know that for this function b to the x plus c, where this is positive right here. If the base is greater than 1, we have an increasing function. If the base is between 0 and 1, it's a decreasing function. But since there's a reflection, here, what I would do is think of it this way. See, if that negative one there, this would be decreasing, right? That's a reflection, so it makes it do what? Increase. So you see it's increasing. So this function is increasing. That's an increasing function. Since there's a reflection. Okay, so that's why it's increasing. So some of you are going to say, well, 4/5 is less than 1, right? And it is. So why isn't it decreasing? it's not decreasing because there's a reflection. And so the reflection, see, this is decreasing, right? But there's a reflection, so you're reflecting it, and now becomes this, an increasing function. Okay? All right, so that was the key to worksheet 4.1, part 3.